Good morning, good afternoon, good evening, wherever you're hailing from, in the words of Chris Short. I'm not Chris Short. I'm Bobby Kessler, Chris's intern filling in today. Chris is having internet issues, but he will be back later on OpenShift TV. But this is another edition of Cloud Tech Thursdays. So without further ado, I'm just going to pass it over to Josh and Amy to introduce our guests today.
Welcome, everyone. I'm Josh Burkus. This is Amy Marek. And we are here with Cloud Tech Thursdays. Today, we are very excited to welcome two of the people behind the MetalLB project, who are going to introduce you to the project and explain what it does. And these are Mark Curry and Russell Bryant. Before we get started, though, a couple of things. One is if you have questions for either of our presenters, then feel free to ask them in chat. And that would be YouTube chat or Twitch chat, depending on how you are tuning in. We will see those questions and we will share them with the presenters. So with that, Mark, Russell, you want to get started?
Sure, I'll go first. My name is Mark Curry, and I'm an OpenShift product manager and responsible for networking. And so part of that is where this comes from. And so the first question maybe that could be asked is, why MetalLB? Why are we here talking about this? How is this important or relevant for OpenShift? Well, as the name implies, MetalLB's primary use case is load balancing Kubernetes services within the cluster, and specifically for bare metal deployments. If you're running OpenShift and if your preferred Kubernetes platform is one of the popular public cloud providers, they already have existing native load balancers that you can choose from for this function. And likely, that choice would be best practices for your public cloud deployment. However, for bare metal deployments, there is no prepackaged load balancer. So this is where MetalLB comes in. And this is why we're investing in the Upstream community for our customers. And this is why also we're targeting full support of MetalLB for OpenShift bare metal deployments as an option in some forthcoming releases. So at this point, I'm going to hand it off to Russell, but I'll be back later to talk a little bit about how this aligns to the OpenShift roadmap. Russell?
Yeah, cool. Thanks a lot, Mark. And thank you all for having me. So my name is Russell Bryant. I work for Red Hat in engineering. I serve as an architect. And there's some of my big interest areas are both bare metal or on-premise environments, and also networking. So I've worked with Mark for a number of years on different things, and the intersection of those two areas is what brought me to MetalLB originally. I'm looking at Kubernetes and the great things that we do with OpenShift in different environments, particularly cloud environments, and looking at how we can improve our experience on bare metal. And one of the I would say gaps that bare metal clusters tend to have brought me to MetalLB. It brought me to looking at the problem space and evaluating choices, and then deciding, what, MetalLB looks like a great solution to the problem I wanted to solve, and getting involved. That's led to me. So as a part of that, I got involved in the Upstream project, and I'm currently one of the maintainers of the project. Is one of the ththings that I do. So let me talk a little bit more about MetalLB, like what it is technically, like what problem does it solve. So if you're using OpenShift or Kubernetes, one of the things that you can create is a service of type load balancer. This is a key fundamental feature of Kubernetes. Now, in a cloud environment, what that's going to do behind the scenes is create a load balancer through a cloud API. Mark mentioned this before, but what about bare metal, right? There's no cloud API there. There's nothing you can do to magically bring up a load balancer. So how can we replicate that experience, that sort of functionality in a bare metal cluster? I mean, there's different ways we could do it. MetalLB is one solution, and one that I think is a pretty good solution. And so how does it do it? I'd say one of the key architectural principles about MetalLB is it's a network-based solution. So it's not about spinning up a bunch of new software. It's not spinning up a software load balancer. It's about how can we provide the right behavior by actually interacting with the network itself. And I'll talk a little bit more about it in a minute what that means, but it operates in 2 modes. Okay, so it has a layer 2 mode and a BGP mode. Now the architecture, before I get into those 2 modes, there's the architecture of MetalLB. It has 2 components. Okay, so one is a controller, and it is just a singleton component. One of these runs in a cluster. And what this controller does is it watches for when a user of the cluster creates a service of type load balancer. And when it does that, it's going to, it allocates an IP address to it. That's really the main thing it does. It's does IPAM or IP address management. So the service, the first thing it does, it creates an IP address. Now this IP address has to be something, it's part of how you set up MetalLB is you allocate a set of IP addresses that are usable on the network that the cluster operates on. And then the real, I guess, core of what MetalLB does is the other component. And the other component is called the speaker. Now, the speaker is a component that runs on every node of the cluster. So it runs as a daemon set in Kubernetes terminology. And this is what, on a per node basis, is responsible for speaking to the network and telling the network about these IP addresses and where those IP addresses can be reached in the cluster. So let's dig another layer deeper. So I've created a service of type load balancer. If you're running MetalLB in layer 2 mode, an IP address will be allocated to that load balancer. And then the speaker will use either ARP, if this is an IPv4 network, or NDP, so that's address resolution protocol or neighbor discovery protocol. We're kind of getting into the network protocol level details here, to announce the location of that IP address. So we've got the load balancer IP address, and now MetalLB decides which node should receive the traffic for that load balancer, and it's going to announce its location to the network using one of those mechanisms. This is core to how networks work, these protocols, and so that's what MetalLB does. It just issues gratuitous ARP or neighbor discovery messages, and then the network is able to reach that load balancer IP address on the node where MetalLB has announced its location. Now, so there's some good things and bad things about this mode. The good one is it's using a network mode that exists like on virtually every network. Like this, it's very compatible. It works almost anywhere. So that's kind of the good thing, and it's good enough for some clusters, or a lot of clusters, I would say, especially ones on the smaller side.
Russell,
yes,
I have a question from the channel, and I kind of had
Sure.
it too. Is the target only for bare metal? And they were asking, or can other prem installations work with it, like VMware? But I was also thinking on that, can it also be used for VMs and other things besides bare metal?
Yeah, I speak of bare metal. I don't know, that's like where my head goes. It's really applicable to any on-premise environment. So I would say any environment where you have the same problem, where it's you're really responsible for the infrastructure the cluster is running on. And you're not, it's anything that's, let's say, not cloud effectively it's appropriate. So I would say that where we see the most demand for it happens to be bare metal, but it actually is applicable to, and I expect that we'll be expanding our support for it to other environments. So a VM environment would absolutely be appropriate. I would say maybe it's some VM environments. I mean, give an example of like where it may or may not apply in a VM environment. Like OpenStack is a good example where it's very applicable to OpenStack in some scenarios and then not others. So if it's OpenStack and you're using OpenStack's like virtual network, so the cluster runs on a virtual network very similar to the type of networking it would be in a cloud, then it doesn't make as much sense, or maybe in that sort of environment you're going all in on OpenStack's its cloud networking. You'd really look toward more like its load balancer service would be a better architecture, in my opinion. Now, OpenStack can also be used in a way where, in OpenStack terminology, they have a thing called provider networks. Provider networks means you're taking the VMs and you're attaching them directly to, well, I say directly, but from a network connectivity standpoint, the VMs are on a physical network that the environment has. And in that environment, it's absolutely applicable here. Like then MetalLB makes a lot of sense. So, it's like absolute. So to summarize, it's absolutely applicable to bare metal clusters. VM clusters, maybe / probably, kind of depends on networking details, whether this is an appropriate solution.
But it doesn't care if it's OpenShift, OpenStack, it'll do VMware or any other
on-prem. Yeah. I was kind of using OpenStack as an example, but VMware would be another one where this is.
It's close to my heart. I'm an OpenStack person.
Yeah,
I appreciate it.
I spent several years working on OpenStack in the past, so I have a lot of background there. So it's always very top of mind for me.
And we did have the question of whether MetalLB is a Red Hat product, and it's not. It's an open source project.
Yeah, and we'll come back to that too, where like it's not a so Red Hat did not start this project. This is something we got involved with because we saw the value in it, and just sort of at our core, we look at what open source solutions solve the problems, and quite often they didn't originate from us, but we want to join with other people that are trying to work together to solve the same problems. And this is a case of that, where we've now joined a community of people that are collaborating on solving this problem. So we didn't originate it. We now contribute to it and help maintain it. And we are going to include it in a Red Hat product as a part of OpenShift. And Mark alluded to that earlier, and I think in a bit we'll come back to that and talk about the sort of detailed roadmap of where the different features are falling in our release schedule. But
yeah, I'd like to jump in on that real quick and just clarify that one of the things that we do at Red Hat is, of course, we support anything that we ship, and as part of that support, we fully test and vet and enterprise harden and do all the things with an Upstream project that we invest a lot in. And so, I've heard the question, will it work with other things? Sure, it will, as Russell articulated, but keep in mind that the part that we're supporting, at least initially, is going to be for OpenShift bare metal deployments. And with the success of that, I'm sure we could grow that footprint of support to other implementations.
Okay. Now we're getting into some detailed technical questions. So decide whether or not this is going to be covered later. So our person who was asking about VMware, Fahad, said, to follow up on that, are you planning to replace the use of Keep Alive D on IPI clusters on-prem? Or is the plan for this to coexist with that?
It's a fantastic question. And so I was actually talking to someone about this morning. And so let me answer it. So the first answer is it's going to coexist at first. Okay, so where we use Keep Alive D is solving some very specific use cases that are absolutely required for these IPI clusters to get them to bring up and function. And we're not going to rip that out immediately. Now, as you can tell I can tell that you know this, because based the question, like MetalLB is performing conceptually the same thing that we were doing with Keep Alive D there. So will we replace it? I mean, and we could. Now we haven't put that on the roadmap yet, but we absolutely could, and it actually makes sense. There's some catches to that as we get into the details. Like one of them is the way we're using Keep Alive D is that we have this as we make that stuff work out of the box. Like as soon as you install the cluster, the way that we're doing MetalLB is that this is an optional component that you can optionally add to your cluster. And so we would have to make that there by default in the scenarios we're going to use it to replace some of our Keep Alive D usage. And so it's a maybe / probably, but not like we haven't planned exactly when we would do it yet, because how we're using Keep Alive D, it works okay for now, so it's not an urgent thing. But it makes sense that we'd be considering it. So sorry if that's sort of a non-answer, but great question, and absolutely does make technical sense. I just don't know when we'll do it. So grab me anytime.
Okay, so you're talking about the two modes.
Yeah,
so you're talking about the first mode.
Yeah, let me tell you about the second mode. The second mode is pretty cool. If you're into this sort of thing. So the second mode is the BGP mode. Okay, so this one is I think really the star of MetalLB. I mean, both modes are effective, but BGP is pretty cool. So this is where again, the speaker runs on every node, and every node then acts as a BGP speaker. So these, every node is then peering with the routing infrastructure in your environment. If you're, and this, so this is only working, this can only work if your network environment can do BGP. So you have routers that your nodes are connected to that can't speak BGP. So the speaker in every node will connect to it. And when you create a service of type load balancer, an IP address is allocated to it, MetalLB will figure out which nodes that IP address can should be, like a route should be advertised for. And what's particularly cool about this is that it will advertise a route to that IP address from multiple nodes, maybe even all of them, kind of depends on scenarios. I'll paper over that for a second. But in almost all cases, we'll advertise routes from multiple nodes. And what's cool about that is that, like, then you get the routing infrastructure itself can provide load balancing. So to contrast this with the layer 2 mode, the traffic is all going to come through one node in the layer 2 mode, because we can only announce via ARP or NDP that IP address from one node. So all traffic comes to one node, and then it can be load balanced within the cluster. It can sort of, go through that one node and then be load balanced from there. But with BGP, the BGP router, since it has routes to that load balancer IP address on multiple nodes of the cluster, it can use ECMP, or equal cost multipath routing, to send different connections to different nodes in the cluster. So, like, what's cool is MetalLB, it actually isn't doing a lot. Like, it's, what it does is it connects to a router and announces routes, but it's now enabling the network infrastructure itself to provide load balancing across the cluster. So it's quite powerful. And again, it's it's relying on just good use of existing network technologies to achieve the behavior we want. And it solves the problem quite well without having to create not running additional software beyond the BGP. Like, we're not adding additional software that's doing processing of the traffic itself. Like, we're not, adding a box somewhere that runs load balancing. We're using the network. So that's really that's the second mode, and that's if for the environments that can use BGP, this is quite powerful mode. So that's the second mode.
All right, 2 questions.
Yeah.
Now this first one might be Mark related. Is there any integration with OKD project? Is it going to have it initially, or it should add after setup? So that's kind of a workflow release process type question. And the other one that is most likely more you is OpenShift support K8's 1.22.x. Actually, that might be Mark too.
So I think that second question is basically, what version of Kubernetes is this aligning to?
It might actually be a more general OpenShift question. That's what I'm getting out of it, which means it's not really for the show. I actually answered it in text with the standard, OpenShift trails Kubernetes releases slightly.
Yeah, but I think we could probably say that there's a good chance this will be Kubernetes. So 4.8 is 121, so it'd be 122 and 123. For across the 2 different modes that Russell was talking about. So coming soon.
And any idea on OKD, whether it'll be part of it initially or it'll be added after setup?
That's a difficult one for me to answer, because OKD is actually not a product. So OKD is a project. So it depends on those project maintainers, but there would be no reason why it could not be included.
Yeah, and I guess one thing I can mention is, from an open source perspective, MetalLB is not going to be installed by default. So that's one thing. So if you install OKD, you will not get MetalLB just out of the box, but you can install it afterwards. And like many things we do in OpenShift or OKD, we use operators or the operator marketplace to choose and install additional components. We've created a MetalLB operator that is now on Operator Hub as of within the last few weeks. So it's very, very brand new from an upstream perspective. So you can actually go ahead and try this out in an unsupported fashion. and you can use an operator to get it deployed in your cluster. So hopefully that answers the question. Yeah, so I think I completed my high-level overview of the different modes. Mark, do you want to just kind of, because you started talking about the roadmap there a little bit about how we're going to, in terms of where we officially support like the different modes and different releases. I cover that now.
Sure. Yeah. Let me go ahead and share. This is one of those things that's probably best viewed as a slide. So we did prepare a slide for this one. One moment, and I will share that. So hopefully you get the big picture there. So the idea is that, today the current default version of OpenShift is 4.7. Very, very, very soon, we will be releasing OpenShift 4.8. And then OpenShift 4.9 is targeting this fall. And that's when that first mode will be made, that Russell discussed. The MetalLB layer 2 mode will be fully supported targeting. And then simultaneously, that's also when the upstream FRR support for BGP capability will be resolved in preparation for the next release, OpenShift 4.10, which is targeting currently the December-January timeframe of this calendar year. And that will provide MetalLB with BGP support. And also targeting BGP with dual stack IPv6 capability support. And then building upon the success of those two primary use cases that our customers have asked for, in the future, we will enhance that. And you can see a few of those topics listed here. And currently we'd be targeting OpenShift 4.12 onward, which would be the latter half of calendar year 2022. So the latter half of the next calendar year. Keep in mind, these are target dates, but so far, everything is looking very good.
Thanks, Mark. And you reminded me of some of the fun stuff that we are working on in the Upstream project. So I mentioned, I'm a maintainer, but there's other people from Red Hat contributing to MetalLB. And one of the first things that we're doing from a feature perspective in the project is this FRR support. So FRR is an open source project that implements a BGP daemon. And that's something that we already use at Red Hat. So we're interested in it, confident in it, and we want to apply it to this use case. So what MetalLB did in the project originally is implemented basically its own BGP stack. So if you were to go look on GitHub in the MetalLB code, it has an implementation of the BGP protocol, or at least a minimal implementation of just enough of BGP to perform its use case. And that has carried the project well so far. But as we look into the future and the additional use cases we'd really like to support, more BGP features, we thought that it would be advantageous to, instead of MetalLB implementing BGP itself, let's switch to another existing, more featureful and mature implementation of BGP. So that's what we're doing. We're adding support for MetalLB to, instead of speaking BGP itself, it will be then managing and configuring, controlling an instance of the FRR daemon running instead. So we feel like that's a better base for us to use as we move on to support BGP. So that's going to enable us to some features we'll get from that like just right away by using FRR, and then just gives us a much more flexible base for BGP in the future. So that's going pretty well. And that's really a pretty crucial base for all the other BGP features that you talked about, Mark. I wanted to mention it. All the other stuff we're doing is like we've been working on CI coverage, improving CI, adding CI tests and new CI jobs in the Upstream project, and lots of general sort of code reviews, bug fixing, that sort of thing.
Okay, and we've got two questions from the channels. What is the recommended option to try MetalLB with OCP 4.8? Let's ask that one first. And then, is there any recommended SCC settings we need to apply on MetalLB namespace?
Yes. So with OpenShift 4.8, I mentioned that there's a brand new operator that you're welcome to try that should, automate some of those requirements, like should automate the requirements for you. You can also just go, and this, you can also just go to the MetalLB Upstream website, and it includes instructions for how to deploy it, sample manifests. It also includes the OpenShift. If you look at the MetalLB website, it has some OpenShift specific notes, including those security context settings that are required for the MetalLB namespace. I don't remember the details off the top of my head, but I know that we have that documented for OpenShift on the website. So, as the roadmap sort of implied, with 4.8, we don't have an official way to try it. Like it's not included in OpenShift officially, but it's open source. It's a component that you can run under cluster. It's not supported by Red Hat, but that's the way you could do it if you wanted to sort of try it out for sure.
Okay. And the SCC settings?
Oh, that one I was talking about the website. I know we have it documented on the MetalLB.
Okay, perfect. And we got another question. Is FRR daemon an existing project, or is it a conceptual project you are planning on working on? And it sounded like it was already a project.
Yeah, it is an existing project. So the website is frrouting.org. And this is a Linux Foundation project. Lots of companies have contributed to it. It's actually, it's not new at all. If you're in the networking space, you may have heard of another project called Quagga. And I think, in any case, FRR is originally based on that from the past. And it's a very mature existing project. But frrouting.org, where you can go learn more about that. It is a very, very nice, featureful routing daemon.
I'm checking spelling, and I'll get that in the chat for people.
Yeah, cool, thanks. And it's some of the other things that are really interesting about it. This is not stuff we have on we have on a detailed roadmap yet, but just kind of imagining the future of another example of why it's powerful. So I talked about BGP, and I talked about BGP because that's where we see the most demand from a routing protocol perspective. And it's what MetalLB already supports, using its custom implementation. But there's also been interest, at least in the upstream community, about can we support other routing protocols like OSPF, for example, and FRR has support for many routing protocols beyond BGP. And so we would kind of have a good base if we wanted to add support for another protocol if we had good demand for it.
Or somebody could join the project and write that.
Absolutely. Yeah, that's another thing. Yeah, pitching the project. The project is the development community is it's certainly on the smaller side, which honestly I find incredibly fun. Like it's a sort of tight knit small group, so it's really fun to work on. So if you're so interested, there's plenty of opportunity for contribution for sure. There's more work to do than we have maintainers and contributors right now, which is a common story on any open source project really that is seeing successful uptick. So.
Yeah, and if you're an OpenShift customer today, and if you have feedback for how it is that we're implementing MetalLB, if you have something that's very important to you in your use cases, please communicate that to us. This is the right time to get it into the queue, and we can prioritize it.
Okay, did you have more basics? Oh wait, you were going to actually cover you actually covered the roadmap already. So
yeah,
you have more basics, or should we just go further with questions?
I'm happy to take any questions that are remaining. I think I've covered the basics.
I actually have a couple myself.
All right, let's hear.
Well, will we wait for the audience to catch up? First, so imagine that I actually we have real bare metal situation, right? I have a cage somewhere, and I actually have the money to buy a dedicated piece of network hardware with like an API, like a Cisco box or something, right? What would be my trade-offs on going that route together with more traditional load balancer thing versus using MetalLB?
For me, it's like I think that it's a couple of things. One, it's not necessary, like because it's you probably have enough in your network as it is with your existing router to do what you need. The type of load balancing here, and I guess another thing is like load balancing is a little bit of a loaded term. When we talk about load balancing, you can think of it as conceptually we're trying to balance load across some environment, but it's used at different layers of the networking stack, right? So it's we're talking about load balancing at like layer 3 level, really layer 3 only in MetalLB's case, and a load balancing product is probably providing a lot of features that are higher level, particularly the layer 7 level. You're going to maybe do some fancy load balancing based on HTTP like destinations, that sort of stuff. So it's sort of like a different problem space. And another one is the sort of the beauty of MetalLB, particularly when we're talking about the way we do it with BGP, is that we're not putting traffic through a box. Like that's the point. We're not funneling traffic through any box or a couple of boxes even. We're using the network infrastructure to provide sort of ultimate scale where we can spread the load directly from where traffic is coming in, the routing infrastructure, to across the entire cluster. We're not introducing a point where traffic goes through. So I guess summarize my answer in two parts. One is a load balancing appliance of some sort. It's probably related to, in most cases, is related to features that aren't relevant to the use case here. And the other is, by design, we don't want to push the traffic through any sort of centralized point at all. We want to spread it as much as possible. And that's the beauty of using the sort of network-based approach here, just putting the right things in the right places so that the network infrastructure spreads the traffic by design.
Yeah, I'll also add that our customers have a very broad set of use cases, and some have pretty extreme performance considerations. Some have pretty extreme configuration requirements, and I would say that if you do have the luxury of having, let's say, a hardware solution that you have at your disposal, and if that solves the gap, then by all means use that. But for all the reasons that Russell articulated, there's the overwhelming majority of our customers are satisfied with the MetalLB solution.
Okay, we have a couple of questions on chat. So in a multi-tenant OpenShift environment, will there be a way for tenants to manage BGP local preferences in MetalLB?
Good question. No, this is a cluster-wide thing. So like at least the way that this is set up today is that this is a cluster administrative level setup thing, and you wouldn't be able to have multiple tenants with separate configurations.
Okay, and then the other question is, in layer 2 mode, what is the average failover time for an IP address from one node to another?
Yeah.
And what's the worst case you've seen?
Yeah, that's a really good question. And actually, I'm going to answer it with more than you asked. So yeah, that's and the reason I say that is it's another place where we can talk about the difference between the two modes and some of the benefits. But so in layer 2 mode, first, failover, of course, is a thing. If a node fails where an IP address was resident, then we have to move it to another node. So there's two things. There's how quick can we detect the failure, and then bring it up to another node. Once we've detected the failure, it's pretty quick, right? Because what we have to do is decide, okay, what's the new node that owns it, and then do what it did before, which is issue those gratuitous ARP messages out to the network, or in DP for IPv6 to say, hey, network, IP address is over here now from the node. So, but the trick is, of course, detecting when a failure has happened. In all of my testing so far, it's been at worst, under 10 seconds the way it is. Which is, not, it's not the fastest. Now, in a previous version of MetalLB, it could be minutes, which was definitely not good. So it's improved to seconds the way it's implemented. It's using a library under the hood called member list, which is a sort of implementation of this gossip protocol. It's doing its own sort of cluster membership protocol for all the speakers to watch out for each other, to be able to detect node failure faster. And so at worst, we're talking seconds. So it's absolutely not the right, if you need sort of sub-second failover times, layer 2 mode will not provide that. And we might be able to tune the parameters of our failure detection to speed it up, but I don't think it'll reach sub-second failover times. But if you can do, seconds, if you can deal with failover time of, say 5-10 seconds, that sort of ballpark, then we're in good shape.
So wait, will BGP support faster failover?
Yeah, so BGP is a better start, will be better for this. So with BGP, first of all, we already have IP addresses actively functional on multiple nodes in the cluster, just due to the nature of how this operates. Traffic can already be sent to multiple nodes, which, first of all, that means if something fails, you're not immediately impacting all traffic to begin with, right? So you're impacting connections that happen to hit the node that failed. So that's the first thing. And then the next thing is, so how quickly can we ensure that traffic is no longer sent to that node that died? Now that is dependent on how quickly actually the BGP router knows, because that's actually what matters in the BGP case. It's when does the BGP router no longer determine a given node a valid route. And that's one of the features we're going to get out of using FRR. Is there's another protocol, like I'm talking networking, it's just like acronym soup. There's protocols all over the place. Another protocol called BFD. Okay, so BFD is a protocol used to help determine link failures fairly quickly, relatively quickly than what you would have otherwise. And so we'll use BFD on these BGP connections to more rapidly determine when the connection between our BGP speaker on a node and the BGP speaker dies, so that the BGP router will say, oh, well, that I don't see that node anymore, so it'll no longer route traffic there. So that'll be quick, and I say quick because that kind of depends on specifics of your routing infrastructure and how we tune BFD. We haven't turned that on and tested it yet, so I can't quote specifics, but this is sort of I would say a standard way of doing this with BGP, and that's what we'll do. And so that'll provide much better failover behavior in the BGP mode. But we'll do our best with layer 2 with the limitations inherent with that mode. It'll be seconds. So much longer answer than what was asked, but hopefully that's helpful. It's a great question. Reminds me of stuff that I should have talked about that.
Somebody has decided he wants to be on the show.
Oh, the cat.
Kitty cat.
Yep.
I have a dog hiding in the corner.
Okay.
I love office pets.
I've got 2 under my desk. Luckily, they're getting along.
Okay, do we have more questions? The kitty is standing in front of the chat screen for me.
Not yet. I was just going to ask if anyone else had any questions.
Yeah. Just to take more questions. Did you have more questions, Amy?
It's been so long since I've used BGP. We had a data center and we were processing credit cards. So it's actually kind of nice to hear that it's still out there, because getting two connections into the data center was always a challenge, financially, and just getting them, knowing that your two connections were being routed in different ways. So it's nice to see that it's still out there and people are using it. I would assume that, yes, we are using not just, one provider for these BGP networks, but we are going with two that are coming in, and then you just configure it based on the information that your provider is giving you.
Yeah, so BGP is definitely alive and well. It is, one of the things that runs the internet. It tends to pop up in the news every now and then when a mistake is made, and part of the internet was taken out by accident. I think that, those things have been improved, I think, over the years, but it's still crucial to how the internet operates. And your comment about the providers thing. BGP as a protocol can be used in a couple different modes. There's the case kind of where I'm talking about, runs the internet, where how all the different providers peering with each other, and then there's, as a protocol, you can use it internally to your organization as well. And that's more the use case here, where, at least in the context of MetalLB, we're only really talking about the BGP peering between nodes of your cluster and then the routers that they talk to. And so, upstream from that, whether from those routers or upstream routers from that in your organization, then you might get involved into BGP peering with other providers and so forth. But we're kind of making use of BGP as a technology just within your data center, within your environment for this MetalLB use case. And it may be that your BG infrastructure beyond that involves providers, but not directly in the context of MetalLB.
Has there been any integration with tools for managing Kubernetes clusters? So things like OCM and kubeadmin and Cluster API. Well, I guess Cluster API is pretty much public cloud only right now, isn't it?
Yeah, well, actually, another thing I was involved in the last few years was starting a project where we implemented Cluster API support for bare metal, where we automated the provisioning of bare metal service and do Cluster API. So that's Metal Cubed or Metal 3.io.
Right.
So anyways.
Right. So can I use Cluster API with Metal Cubed?
Yeah. So
deploy MetalLB?
You absolutely can.
Question.
There's not direct integration though. There's a, it's like you can use that to bring up your cluster, and then once you have a cluster, then you install MetalLB. But like we haven't done anything anywhere where it's just automatic. So as a part of, I've installed my cluster and it includes MetalLB out of the box. It's always sort of you're going to take a next step. And the two things that exist in terms of doing that, there's the operator. So you can add MetalLB via that operator, or there's the Upstream project. We have a Helm chart. So if you want to use Helm, you can use that to deploy MetalLB. We also just have like sample manifests for like quick hack of a deployment sort of thing. If you want, you can grab our manifests as is, or with slight modifications if necessary, and use those to install it on the cluster. But no direct integration with any of those things today.
Okay, we have a question came in. When OpenShift adds support for MetalLB, is the intention to use BGP/layer 2 for the cluster API and apps ingress, or just for user workload ingress?
Yeah, great question. So to start, it's just going to be user workload. So it's not going to be used by default for any of the stuff like our cluster ingress controller. Like we kind of talked about this a little bit earlier, where MetalLB technically and conceptually is applicable to that, and we very well could migrate our default setup to use MetalLB at some point in the future. But to start, we're providing this as an optional component targeted at user workloads. But that's a natural sort of evolution of it, that we may then replace some of the stuff that we used. This is what we were talking about earlier with keep live D, where that's kind of a sort of a more manual, very focused use of keep live D for a couple of specific use cases, we could then go back and use MetalLB for those in the future. But that's what we're doing out of the gate.
Yeah, so we talked a lot about the OpenShift support for MetalLB.
Mm-hmm.
Do any of the other Kubernetes distributions have MetalLB integrated?
Good question. And I don't. So I'm trying to see how quick I can pull up the MetalLB website to help me remember this. So like there's a part of the MetalLB website, there's a list of like different environments where it's been used. I don't know about distributions. I don't know offhand of any distributions which distributions include it. I don't remember. But it would be, I guess the question to ask is, and I mean, I've seen lots of people say with K3S using it, like just as an upstream maintainer on the issue tracker and stuff. I see people using it with that.
Okay, well, that would be distribution.
Yeah, I'm trying to like dig into my memories and see if I can remember. So K3S, yeah.
I can see there's some setup guides for using K3S with MetalLB. So
yeah.
With there are some, for example, there are some NEPs, NEPs out there that have sort of bespoke custom deployments that they use, where they have integrated MetalLB to some extent. But what our customers are really asking for, what the bulk of the customers out there are asking for, was for FRR, BGP, MetalLB, and that does not exist anywhere. And so we're basically working with Upstream to create it as the first.
Yeah, that's a good point. Like when we were looking at this, we have problems we want to solve. What are our choices? What we chose was we want to use MetalLB as the community and help jump in and help evolve it to solve what we want to solve. Another option we had was to do something more, basically more custom, start something brand new around FRR, but that just didn't seem to be the right choice. This was a very active, very actively used project that was like lots of things as an open source, right? It's like, that's really cool. It does a lot of, like, it's almost what I need, right? So let's jump in and collaborate with others to make it what we, exactly what we need. So that's what we're trying to do.
Cool. So is anybody in the project talking about joining the CNCF?
Oh yes, in fact. So some upstream project history. So this is the MetalLB, the project was started by one guy originally, but he has since moved on, and now there's a team of maintainers, including myself, that take care of the project. And he still owns the domains, and there's some sort of like, let's finalize the sort of handoff of the project to long-term ownership discussion. And as a part of that, we did apply for the CNCF sandbox, and it is in the queue for review at this stage. So that's the discussion that I helped drive and put in a proposal to the other maintainers to say, this is what I think the right thing is for the project. And we reached consensus, and I did the application. Yeah, we are in the queue for review. So cool. That's the future I expect, or that I hope for. I think it's that seems like a natural home for it. It's a Kubernetes specific project. So hopefully that goes through. And it's a healthy dev community. I work with people from, so there was a company named Kinfolk who has now been acquired by Microsoft. That there's a couple of maintainers from there, and then another maintainer from who works for Rancher. And then other contributors from elsewhere. But so I think CNCF would be a great home for us.
Cool. Well, I think that's all the questions we have. So, any final thoughts on MetalLB, the future of that, future of load balancing?
Future of load balancing. No, I don't know. I don't think so. I just thanks for having us. This has been a very fun project. Of course, I do this as part of my job, but it's been one of those things that's kind of been super fun for me. Just because this is like nice intersection of things I'm interested in. So thanks for the opportunity to come talk about it a bit. It's fun.
Yep. I'd also like to thank everybody for their time and our ability to speak about it today, and look forward to hearing from all the customers with their requests for enhancement and so forth about MetalLB, and love to have those discussions.
Okay. Yeah, actually, one quick question. Is there a Slack channel or a mailing list where people can follow up if they have questions later on the project?
Yeah, so the Upstream project MetalLB, there is a MetalLB users mailing list. It's a Google group, and you can find the link on the MetalLB website for that. The project also has 2 Slack channels on the Kubernetes Slack. So there's MetalLB and MetalLB-dev. Those 2 channels are active on the Kubernetes Slack. So those are the 2 places from the Upstream project perspective. And then, Mark, how do people reach you if they have any product questions or requests, that sort of thing? What's the best?
Basically through their account team. So if they're a OpenShift customer, they should have a connection point there. And then depending on the level of support they have, that is different. But that is definitely the way to approach it. Customers can't submit requests for feature enhancements directly, but the account team does it on their behalf, and that gets it into our queue. And at which point we evaluate it, and if it has merit, and we will build it into the future of the product.
Cool. Awesome. Well, thank you so much for attending and letting us know all about MetalLB, and how to use it and what's going on with it. For anybody tuning in who say missed the beginning of this broadcast will be archived on YouTube, so you can go back and watch the beginning of it. And of course, we have lots of different shows here on Red Hat and OpenShift streaming. Just so everybody knows, this particular show, Cloud Tech Thursdays, is actually in 3 weeks going to become Cloud Tech Tuesdays. And we're going to be moving to a new Tuesday time slot at 10 a.m. Eastern time. And that's in order to accommodate more of our European viewers. So thank you very much. And we will see you online.
Thanks for joining us, everyone.